Okay, so in this video, I'm going to talk about sets in Python, and the contents of this video will be how we can define a set in Python, how we can create a set from a list of items, how we can add and remove elements from a set, how we can look up elements, and how we can perform the basic union and the intersection of sets as in a mathematical set. So sets in Python, they are also a type of a collection, means they are used to represent collection of things or objects, and you can actually have different data types enclosed inside a set. So, but like lists and tuples, sets are unordered, means the position of the element is not recorded in the case of a set. And additionally, sets also have unique elements, means duplication of elements is not allowed. It is possible in, for example, lists. Lists can have several copies of the same element, but that is not allowed in a set. Even if you input several copies of the same element, when you try to output the set, it will just show one instance of that element. For defining a set in Python, we make use of curly braces. And for example, if I want to declare a set with these elements, like Rose, Jasmine, I have missed inverted commas here because I'm storing these as strings. So now you can see here more than one occurrences of Rose and more than one occurrences of Daisy. So when I try to output this set, it will be having just one occurrence of Rose, as you can see here, and one occurrence of Daisy, as visible from these arrows. So a list in Python can be converted to a set using the function set. For example, I have this list in which again I have multiple occurrences or more than one occurrences of Rose and more than one occurrences of Daisy. So when I invoke the set method on this list, so this is going to be a set which will contain a set which has been created from this list 1. So it will return me a set and it will just show me the elements without duplication. So I have just one occurrence of Rose and one occurrence of Daisy, as visible here. So new elements can be added in a set using the add command. For example, this is my set with which I am starting. If I want to add another element, I can make use of the add command and I can add another flower in this one, flower name. And now if I try to output this, then I will have the element marigold added in the set. Adding the same element again will not change the contents of the set because duplicates are not allowed in the case of a set. An element from the set can be removed using the remove method. And if we invoke, for example, the remove method for this parameter daffodil, then this instance of this daffodil will be removed from set 1. And now if we try to output and see the contents of set 1, it will not have daffodil included in it. Likewise, if we want to check whether a specific element is present inside a set or not, we can make use of the in command, and that will just return a boolean whether if the element is present, then it will be true. If it is not present, then it will be returning a false. So for example, Rose is present in set 1, so it will return a true. Daffodil is removed, so if we try to invoke in command on the daffodil element, then it will return a false. So in mathematics, we often take the intersection of two sets. So in Python, you can take the intersection of two sets by making use of this AND operator. So it will be returning the common elements in two sets. For example, set 1 has A, B till F, and set 2 has D, E, F till H. Now, if I want to take the intersection of set 1 and set 2, I can store these in set 3, and I will get the common elements D, E, and F, which were present in both the sets here. So set 3 will be the intersection of the sets S1, set 1 and set 2. Likewise, we can take the union of two sets, which will return a set which will have the common elements listed as one, and other elements also included from both sets. For example, if we have set 1 having A, B, C, D, E, F, and set 2 D, E, F, and I try to invoke the union command, the union method here by passing set 2 as parameter, then I will have set 3, which will have the instances of elements from both sets and the common elements just once. And there is also the containment relation checker possible, that is done through this is subset method. And if I try to invoke this method from one set to the other, it will just test whether the second method is contained in the first method or not. For example, set 2 is subset of set 3. So we're just checking that whether set 2 is contained in set 3 or not. So in this case, it is contained. Therefore, we will get the answer true from this method. It returns a true or a false always. So now it's time to switch to the Google Colab demo of sets. So let's go to the demo. So now, for example, if I want to create a set, let's call this my set. And let's pass it's a bunch of elements, 1.5 and 111, for example, and just try to repeat the first thing. And now I want to see what is inside my set. So if I just control enter, here you can see that the elements are listed which are mentioned in the definition 12.5, 111, and ABC was present there twice. So the set notation has just listed it once because there is no duplication allowed in the case of the set. And this curly braces notation is used to represent sets in the case of Python, and Python interpreter understands that this is a set by identifying these curly braces. So if I want to create, for example, a set from a list, so first let's say I create a my list, and it will be in square brackets. Again, let's say we have two ABCs, and let's say 12.9 and 345. Now I want to have my set 1 equal to set my list. Now I want to see what is in my set 1. It should be a set containing elements which are there in the list, but duplicates are being shown just once. So you can add elements to the sets by using the add method. For add XYZ in the first set I created. So let's call this XYZ, the new element, and now I want to see what's inside the set. Press Control Enter, and here you can see that XYZ has been added. Likewise, you can also remove some elements from the set by the remove method. So let's say we want to remove 12.5, and now I would like to see what is inside the set. So 12.5, yes, 12.5 from this set, my set has been removed, and now we don't have the instance of 12.5 integer in this inside the set. So if we want to look up something inside the element, so we can make use of the in command. For example, if I want to see whether 111 in my set, if it is there, I will see a true, and if it is not there, then I will see a false. For example, if I will 1113. We can also have the is subset relationship, or sorry, we can also have the intersection and union. So let's try that. Let's say we have a set A, yes, or set 1 to So 1, 2, 3, 4, 5, and set 2 equal to 3, 4, 5, 6, 7. Set 3, I want to take the intersection of these two sets. It will be set 1 and set 2. I want to see what's inside set 3. I just need to invoke this command. So 3, 4, 5 are the common elements. And if we can also do that by set 1 dot intersection set 2. So it will result the same. 3, 4, 5. Now, if I try to take the union of these two, so in that case, set 3 will be having all the elements of set 1 and 2 and the duplicates with listed just once. So that's it. Now, if I try to check whether set 1, let's convert this to intersection. And now set 3 will be having just the common elements of both set 1 and set 2. And we want to see whether set 3 is subset of set 1 or set 2. So we expect to see a true, and if we make it the other way around, then it should be a false, because that set 1's element, all the elements are not contained in set 3. So that was all for today's demo. Thank you very much. See you in the next video.